is that on the table? Like 8, 9?
It depends on how pedantic the person you're playing against. Because if you know your stuff, you can just speed through it.
Right, yeah.
But if you're having to look up every rule of every unit of your entire army every turn because you have the memory of a goldfish,
Yeah.
the game takes like 6 hours.
That's like all of Warhammer.
You got your headphones with you?
Yeah.
I would plug it in there just so you can capture the audio, but it's not coming through the speakers.
Shit, I got that. Can I just post? I'll do both, I think.
You should be able to just select Discord as an audio input source.
Oh, yeah. Well, actually, it won't. It's weird. It won't, yeah, you're probably right. Properties.
Properties.
No, that's your microphone. Hit cancel.
This one?
Yeah, do that one. And then
Properties.
Alright, I never figured that out yet, as far as how to select for the audio source.
Or speakers.
Or hold on. Let me share the application.
I think I got it.
Stream.
It's recording, right? Yeah.
Yeah, I just didn't want where you're speaking, it's coming out of these speakers and you're just hearing yourself too.
I just won't say anything.
We change to the application.
Address translation. It's network address translation. What's P? Port address translation.
Yep. Alright, are we ready?
That was a guess.
Cool. So, we're going to talk about a couple things in this lecture. BGP, Border Gateway Protocol. It is our exterior gateway protocol, the routing protocol of the internet. We are also going to cover port address translation, PAC. This is translating IP addresses from private to public while minimizing our public IP usage. These two technologies collectively enable us to utilize the internet. Without either of them, they wouldn't function. And this, BGP just because that's how the routing occurs. PAT because of the limitations of IPv4. We only have 4 billion addresses in IPv4, and I'll tell you what, we're at way more than 4 billion people. And how many devices do you own that have an IP address on them?
At least 5. At least 4.
A bunch.
Smart homes.
So you start 8 billion people times 5 devices plus public infrastructure. I mean,
40,
you're
50.
looking at tens to hundreds of billions worth of addresses in use. So in order for us to actually make IPv4 work, we need to translate and use some of those addresses over and over again. That was outlined in something called RFC 1918. Have we talked about any RFCs before?
No, I think I just heard it in a video recently.
Okay. So RFC stands for Request for Comment. Basically, it's a giant forum post for the world's engineers to submit ideas and have them reviewed by the international community. And if, everyone agrees that they're a good idea, nobody really objects to anything in particular, they will become policy.
Wow.
So RFC 1918 broke the IPv4 address space into 2 groups, public and private. The private space is the TENS network, the 192.168 network, and I think it's 172.12.
Is this the classes? The AB?
No,
Okay.
this is not
These are just
classical
private.
networking.
Okay.
These 3 ranges are reserved. You will not find them on the public internet. That's because every single private network, whether it's a company, it's your house, it's a government institution, they all use these same 3 address blocks and they get translated via PAT into a public address. So that one address can represent all of these.
It has to turn into public so it can function with the internet.
Correct. You have to translate from a private address to a public address. So what that's effectively done is it's allowed us to multiply this private address space by the number of public addresses we have, which is a lot. It's how we've been able to kind of limp along with IPv4 instead of cutting over to IPv6.
It's not telling me.
What's the Band-Aid?
It is a Band-Aid, you are correct. Okay, but before we get to all that fun stuff, we're going to talk about BGP. So it is our one and only exterior gateway protocol. Its predecessor was exterior gateway protocol. So BGP is the successor protocol. Like I said earlier, it's the routing protocol of the internet, and it utilizes TCP port 179.
Wow.
All of its
Specific.
communication is reliable. Why is it reliable?
Is it because it's chasing hops?
As hops, remote as. Because everyone uses it?
How does TCP work? Anybody know?
No, I don't.
No.
I'm not even gonna
Okay.
Google it.
Blank.
So there's two primary transport layer protocols. UDP,
BGP
And
and
TCP.
TCP/IP.
UDP just yeets the packets into the ether.
Okay.
I hope you get it.
It's packets into ether.
TCP creates an ordered list of packets. And it will send all of them. And the receiver will see, okay, this is packet 1 of 264. This is packet 2 of 264. Packet 4 of 264. Wait a minute. Where's packet number 3? I'm missing it. Hey, give me 3 of 264. I missed it. Then it will get resent and added into the list. It is a reliable protocol in that it keeps track of the order in which information is supposed to arrive, and it will make sure that it receives all of the packets. UDP does not.
It just sends out them.
It just sends it, and if you get it, great. So UDP is for low latency. Things like this voice call that I'm in right now for Discord,
Video
or
games.
streaming services, or video games. Yep, that's why you can lag out and have weird shit happen. Well, you lost a bunch of packets somewhere, and the game had to figure out what you were doing.
What's going on?
Yeah.
TCP, on the other hand, because it can take a while for that, hey, I missed this thing, please retransmit it. Oh, okay, I received the retransmission, let me put it back in the correct order. That takes a while.
Just-
Can't use it for those kind of fast-paced applications. But it's really good for delivering messages. Web pages, BGP, making sure that the information that we're supposed to have actually gets there. Okay. And then the last thing with BGP is that it is a path vector protocol, like EIGRP. Only instead of measuring individual routers as a hop, it instead measures entire autonomous systems. So there could be 100 routers in this network that it traverses internally. But it only counts as a hop, if for BGP's purposes, once it moves to another network. So this 7922 right here, this is representing Comcast. That is one of their actual autonomous system numbers. So that is the entire Comcast network, which spans a huge portion of the country. That's why, even though, you know, there's probably hundreds, if not thousands of devices between here and Google's data center in Chicago, it only shows up as like 14 hops. Because we don't see all the internal traffic that Comcast is taking care of for us. We just see entry point, exit point of the Comcast network. Does that make sense? Okay. And a lot of that has to do with how service providers handle traffic internally. We don't need to understand any of that. We're not going for a service provider, CCNP or CCIE, so we're not going to touch it. Now, if that's something you want to learn more about in the future, great, go for it.
Gotta get really cranky.
Never know.
That's a lot, the CCIE. Jeez.
I heard a little bit about it.
2,200 to take that?
3,800.
Oh my gosh.
Plus you have to fly to LA.
Yeah, because there's only 2 places in the country where they'll have their labs. Yeah. I don't know about that one.
Well,
But they said only 0.6% of all IT professionals have a CCIE.
oh, it's got to be lower than that.
And they said like that number is like the biggest flex you can be, right?
I mean, you could be a DE. I think there's like 7 people on the planet that have that.
Holy crap.
Does that even count as a? I think
Yeah.
there's only 7 people who have it.
Yeah, I think you have to have multiple CCIEs before you're even eligible to be invited.
Oh,
take
good
it.
lord. Jeez Louise.
Oh.
The DE is like owning a Ferrari. You don't just go buy a Ferrari. You
Yeah.
have to
You be invited.
be invited.
Yeah,
to
oh
my
buy a
gosh.
Ferrari.
Yeah. You can't. You can have the money, just can't buy one.
The CCNA is peasantry, I guess, compared to the DE.
It's also not really a useful certification.
The CCNA?
No, the DE.
Oh, there, yeah.
If you're at the IE level already,
That's all they want, pretty much, right?
We're just doing side quests.
Yeah,
It's
the-
DLC.
DLC content.
the big reason why companies want IEs is because Cisco offers you a discount on everything that you purchase from them,
Oh, wow.
equal to the number of IEs in your organization.
That's insane.
Wow.
So Cisco is very cleverly promoting their own certification process by offering discounts, which gets companies to buy into their infrastructure
Right.
and have their engineers take the certifications so that they can get cheaper infrastructure.
Wow.
Sheesh.
It's genius from a business perspective.
Yeah.
Not bad from my perspective, though. 3,000. Do companies, are they the ones that usually pay for that certification? The
They'll usually
3,800?
reimburse you.
So, oh man.
It's probably not cheap either. But is it still like? Is it
But if you have an
Yeah,
IE,
imagine
you can
failing
also
that.
basically just write your own paychecks. So.
Oh yeah. I've heard that a couple times. That's how rare they are.
Okay. So, autonomous system numbers.
Let's do
Each
6-4.
group of routers running BGP will utilize an autonomous system number. Josh, we're recording it for you. Go rest. Okay, thank you.
Oh, he does sound really sick. Poor guy.
What?
So he does sound sick. I don't.
I didn't tell him to hop on. Yeah.
Really hands it up.
Okay. Okay, so there is a large range of valid autonomous system numbers. 0 through 65,535. Of those, we have a couple different ranges. So some are reserved for various purposes. And then there's also a large block of public autonomous system numbers, 1 through 64,495, and a large block of private AS numbers, 64,512 through 65,534. So this whole thing is controlled by IANA, the Internet Assigned Number Authority. You have to pay for a public AS number. You can use a private AS number within your organization willy-nilly, does not matter. They are there for companies to use internally for using BGP internally, iBGP. We'll talk a little bit more about iBGP coming up here.
That's cool.
What was the last one?
Last one is reserved, 65,535. Alright, so, just like with the other routing protocols that we've learned, BGP has its own table. This is a list of prefixes known by BGP. Prefix is network address, plus subnet mask. So instead of just sharing the network address, you're sharing the network address and the subnet mask. Where is this network? How big is it? With those two pieces of information, you know exactly what range of IPs something is talking about. So BGP shares prefixes. And the way that you share prefixes with BGP is by already having them in the routing table. So the flow goes something like this. You have a network. Wow, that was way off. You want to advertise it to the public internet. You need some sort of internal routing. This could be static, EIGRP, OSPF, whatever it happens to be. It needs to be in the routing table already. You then add it to the BGP table. We'll talk about how you add it in a little bit. Sneak peek, it's network statements. BGP then shares it with your neighbor. So if you do not have this step, the exact prefix is not in the routing table, it cannot be in the BGP table. This is a chain of dependencies. You cannot have something in the BGP table without it already existing in your routing table.
So you would need OSPF, regardless?
OSPF, EIGRP,
Just
statics,
one of those?
you need something.
Okay.
BGP doesn't care where you learn it from. It just needs to exist.
Okay.
You cannot reference an object that does not yet exist. You know, this stack of $1 billion right here, Josh, I'm pointing at the ground with nothing on it. I would like to spend my $1 billion on a Ferrari. Oh wait, I can't because I don't have the $1 billion. Object dependency. Besides, I wouldn't want a Ferrari anyway.
What you want, a Porsche?
Tessie.
I do like Porsche. That's my favorite.
If I had to pick a DBS from 2008,
Okay. Aston?
Aston Martin,
Yeah.
aka the Bond car. from
Yeah.
Casino Royale.
Yeah. That's the one.
So sexy. I've got to sit in one when I was working at the valet of the airport. Okay, so network statements are how we get routes from the routing table into the BGP table. They must match an exact prefix. So if you have, 10.2.69.0/28.
It's
and
private.
10.2.69.8/28, whatever it happens to be. I can't advertise 10.2.69.0/27 because this is not in the routing table. I have a pair of 28s, I do not have a 27 in the routing table. It must match exactly. Now there's ways to cheat it, I'll teach you that. But that's a very, very important concept that I'm trying to get across.
Object dependency.
It must be in the routing table in its exact form that you want to share.
Must be in the routing table. So it's gonna. Oh, that's later.
Must be in the routing table.
I don't know where the whiteboard went, but there's a whiteboard with 5 steps. There are 5 questions to ask yourself
Oh, it's over
when
there.
it comes to BGP.
It's on. It's in AD.
Yeah, we'll wheel it back over because it's relevant now. Okay, so network statements does not create neighbor relationships. That's where BGP differs a little bit from our other interior gateway protocols. The only purpose for a network statement is to add a route to the BGP table from the routing table. And they don't use wildcard logic. Much
Hey.
simpler.
Yeah. That's a plus.
It's our network
It is a
statements.
That's how it should be. So if I didn't make it clear before, the large bold red text should make it clear right now.
More light in caps too.
The exact prefix must exist in the routing table. If it doesn't exist in the routing table, so that example that we had before where we had a pair of /28s, but we wanted to share them all as one route, a /27. We can do it. We have to cheat a little bit. The way we do that is by using something known as a null route. A null route's purpose is to artificially add a summary to the routing table. That's the only thing it does.
That's a cheat. Okay, I remember going over that.
Yeah, null route can be a bit of a brain bender. I know I really struggled with it as a concept when I was going through the program. But all we're trying to do with it is if we have 2, 4, 8 routes that we want to share, but we don't want to share all 8 individual routes, we just want to share one summarized prefix, we create that summary using a null route so that we then share only the summary. That's all it's doing. Yes, Alex?
Would that be in our whole network? So for example, for lab 3, we can come up with a whole summary which comes out to like a /24. Then we can just put that into our IP routing tables on our routers.
Exactly.
Easy. And that would have to go on each router, not just the
No,
Illinois?
no.
Oh, okay.
Just Illinois.
It'd be the Illinois and the Sea Ice Cream router 1, I believe.
Yeah.
Yep.
Because they redistribute the statics.
Yeah.
Now, not because they redistribute the
Okay,
stats. Because the Illinois and the CIS1 router,
yeah,
those are the routers that are forming the BGP neighbor relationship.
gotcha.
Now, the reason you can use that
That'd be SIC router 2, right?
SIC router 1.
CIS router 1 and router Illinois. The reason why you can use this cheater summary route, the null route, is because once the traffic gets to router Illinois internally has more specific routes. Because remember, we use the longest match rule to determine where our traffic actually goes. So the entire purpose of this null route is just to say to the public internet, hey, I have this block of addresses. If you want to talk to them, send your traffic to me, I'll handle it from there. And from there, the internal routing takes over, Bob's your uncle, everything's fine.
Nice.
Does that make sense?
Yeah, yeah.
Okay.
So it'd be because they're BGP neighbors, not because they're regions. Okay.
Correct, because they're BGP neighbors. So,
That.
it is a route to nowhere. Don't let that trip you up. All that means is if for whatever reason you were to match on this null route, it would drop the packet. But you should never be matching on the null route because of the longest match rule. Some other more specific route should be taking that traffic for you. Frankly, if you end up having packets that are matching on your null route, it's probably because you put the wrong null route in. Or your internal routing collapsed for some reason, like an outage on a router. In which case, what the null route does is it prevents traffic from looping and ping-ponging around the network. It'll just drop it until you resolve the problem. I need to use the restroom. I'll be back.
There we go. Fucking crack addict over there, dog. What the fuck was that? I need my vape. fucking sucking on it like a titty, dog.
And for some reason, I keep forgetting that SIG router 2 is on the bottom. And
You're right. So yeah,
that's why I asked that question. I was like, 1's on the top.
I think they want us calling it CIs. It's the second. Every time we say sick router, he always corrects it to CI. So I'm like, oh, all right. Fair. So I think what we're missing, we have our null routes on our labs though. Yeah. Got all my shit ready to turn in. Whoa. Oh. I think we're gonna have to continue this. What time is it? 10:36. So now we still got tons of time. I need to cut out like 5 minutes from this recording.
Huh?
As Joe is in the bathroom. So we're only 30 minutes in.
Slideshow or no?
It's literally like my pitch.
Yeah, I'm literally just going to just talk about a game. I might bring up a couple pictures, but
Perfect. I still got mine recording, I hope. See OBS. Yeah, the screen recording. And the mic.
Yeah.
Oh, so it's probably gonna hear me freaking grumbling and talking to myself.
Yep.
Oh shit. Sorry. Sorry, Josh.
Then if you want to share it, just upload it to YouTube and just label it as private.
Oh yeah, yep. We'll do that too. Was that you? This PowerPoint's gonna be on nutrition. Are you freaking serious right now? That's cool. Mine is the opposite, Mike. Mine is on food, right? Hot pot. Very unhealthy. dare you to do yours on anime.
No, I'm just gonna. I was literally gonna wing it, but now I look like I'm the worst one because.
It's
you
the
guys got-
introduction. Me and Mike are going too hard for this.
Yeah.
Because they want to pick apart our, so no matter what, they're going to pick us apart. No matter what we do, how good you are, they're going to still give us advice on what we need to improve. I already know what I need to improve. Kind of. I look at the screen too much and I say, too much.
I do that already, but.
It's all the ums and the A's. And they're going to like try and mess us up too. So like, you got to stick to your point. Like mine's on Hot Pot. They start going on about China and stuff. You got to bring them back. Like, hey guys, like we'll discuss this maybe in next week's meeting, but for right now, let's focus on Hot Pot. So look, I see it in their eyes. They're ready to tear us apart.
Yeah.
Gonna have a lot of fun, but not us. No.
Oh, sorry about that.
Gotta pay.
We still recording?
Yeah, this whole time.
What are you giggling about, Alex?
I just dropped my pen, so now I gotta hike all the way over there.
You better go get it.
Fucking through it. Jesus.
Okay, so the way that we configure a null route is like so. It uses the same base configuration as a static route because it is a static route. The difference being, instead of the next hop of some IP address,
Put null zero.
null zero.
So to be clear, if we do not have the null route in, our BGP tables and in general just will not work.
Correct.
Okay.
Because we are trying to advertise summaries, we need to use the null route.
Let's see.
If you were just sharing everything that you do in BGP,
Yeah.
all the tiny little routes, you wouldn't need one.
I see.
But there's a couple problems with that. One, means you're gonna have to, once we get to the filtering lecture, you're gonna have to make a really detailed and intricate set of filters, which is a pain in the ass. And two, I don't like spamming the routing table of the internet. It's already 927,000 prefixes long. I don't need to add 10 more to it. I'd prefer to add one.
Right.
Make sense?
Yeah. Yep. Need that catch-all.
So one part is your own your simplification of your network. The other part is common courtesy to the rest of the planet. So it is used to ensure that the exact prefix that we want to advertise is in the routing table. All right, BGP neighbors. They are manually configured. They're not dynamically discovered. This is because BGP is our company interacting with another company. We do not want that to be automatically discovered. That leaves us open to some bad actor spoofing and automatically forming a neighbor relationship and sharing bad routes with us, doing bad things to us. So in order to prevent that, we are manually configuring our BGP neighbor relationship. Both sides need to agree and consent. to the relationship. The way that you do that is you have, you know, the Aspen network here. It's what? 6.3.2. Student number 17, something like that.
Yeah, I think so.
We have the Comcast, which is 6.3.2.69.18. Each device will need a statement saying, I am this person, I am expecting to talk to this autonomous system number, 7922, and I should be receiving my response from this IP address. It is extremely explicit. Comcast will have the same thing. I expect to receive I am trying to talk to ASN 169, and I expect to receive the reply from this IP address. And if both sides match and they agree, then a BGP neighbor relationship is built. Does that make sense?
No.
Okay. So, two things. If you have, or depending on your autonomous system number, determines what type of BGP connection you have. If you are forming a neighbor relationship with some other device within the same autonomous system, 169 over here, 169 over here, that is IBGP, internal BGP. It's not necessarily super widely used because it's a bit of a pain to work with, but it's hugely flexible in that it allows people to shape their traffic and tell it how to behave. So for large or distributed networks, it can make sense. If you are forming a neighbor relationship between two different autonomous system numbers, like the one we have drawn here, that is an eBGP relationship. External BGP. And then we have our neighbor states listed here. So idle, never heard from our neighbor. Active, we have sent a message saying, hey, we would like to form a neighbor relationship. It will have to establish a TCP three-way handshake. Do we know what those steps are?
SYN, SYNAC ACK.
SYN, SYNAC, ACK. So, hey, I'd like to talk to you. Okay, I agree to talk to you. Great, we're talking. Three-way handshake. It's to ensure that both sides, one, want to participate and understand that they are participating. Because if I have some weird, funky routing and my SYN ACK never gets back to the original source, do I want to just start blasting private information across the open internet? No. One, that's a waste of our time, and two, nothing's getting done. So TCP uses a three-way handshake. I'm initiating this conversation. Very well, I agree to respond and participate. Great, let's do this. And then they actually send data back and forth to each other. So connect is after that TCP session has been established. You will then send an open message. All right, so now that we're talking to each other, we have a conversation going. I would like to become your BGP neighbor. And then Henry will send his response saying, you want to be a BGP neighbor? Cool. I agree to become your BGP neighbor. Here is my information. I compared it to the information that you sent me, and as long as both sides agree that the information looks good, the adjacency is established. Only then do we actually exchange our BGP tables. So it's a long process to actually get set up here. BGP, because it's dealing with different companies interacting with each other, is intentionally very slow and very deliberate. Now, by very slow, I'm talking in computer terms, meaning it takes a couple of seconds instead of milliseconds. The other reasoning for that is if we had a condition known as flapping, so a neighbor relationship was going up, down, up, down, up, down, up, down, up, down, up, down, because there was some problem, bad cable, whatever. Do we want to be spamming update messages to the service providers and the rest of the routing table of the internet? No, nothing would get done. The whole world would just be flooded with update traffic and no actual traffic would occur. Because there are hundreds, if not thousands of networks that are going up or down all the time. BGP is intentionally slow to converge so that if you have a condition like that where it's just flapping up and down, it'll sit there and say, I'm gonna just wait till you figure your shit out. Okay, you've been up and established for like 10, 15 minutes? Cool. All right, now I'll send an update. It's to prevent update spam throughout the global internet. Does all that make sense so far? Cool. All right, so in order to form that neighbor relationship, you need a neighbor statement. For each neighbor that you are becoming or establishing a relationship with, you need a separate neighbor statement. So if I'm, let's say I'm the Aston network, and we have 2 business class connections and a backup cellular connection because we like redundancy. Alex, your Comcast, Henry, your Verizon, and Mike, your AT&T wireless. I need a separate network statement, one for Alex, one for Henry, one for Mike.
Oh, wow.
And you will each have one for me in return. Does that make sense?
Yeah.
So it specifies the IP address and the autonomous system number of your peer. And that peer must have that mirroring statement, like in the example that I drew up. So I say, I am Joe, I have autonomous system 169. I'm looking to form a neighbor relationship with Alex, who is Comcast. You should be autonomous system number 7922. And you should have this IP address, 63.2.69.18.
Right.
And I send that information over to you. When you receive it, you say, yep, I'm Alex, Comcast, 7922, and you sent it to the right IP address. This is the IP address that I expect you to be coming from and your autonomous system number. As long as both of our information matches in both directions, we're good to go. Mirroring statements. Kind of like redistribution, if that helps. So, just like all the other dynamic protocols, we have to turn the protocol on. Router BGP, and then we are specifying our autonomous system number. You then create a neighbor statement. So I want to form a neighbor relationship with this address, and I expect him to have this autonomous system number. Alright. BGP, just like our other routing protocols, can participate in mutual redistribution, or just one-way redistribution. So if you took care of already summarizing all of your networks in OSPF, all you have to do is redistribute OSPF into BGP. That way, you wouldn't even need a null route. That's if you had already created summary statements in OSPF. So the null route is only if we don't already have the summarized network that we're trying to advertise in the routing table. Does that make sense, or did I just confuse the issue more?
I mean, that makes
Repeat it
sense.
one more time?
Sure. So if I create a summary for this entire OSPF area, you know, 10.2.69.0/24, I just have that as a network statement in one of these routers, so it's already in the routing table. I can redistribute and add that to BGP. And because this is the summary that I want to advertise, I don't need a null route, because it already
It's
exists
already-
in the routing table.
Gotcha.
Did that help, or did that make it worse?
No, it helps.
Okay.
How would you do
I
that?
saw you cover your mouth and start.
I think that's like my next question.
So if
If it wasn't summarized, then you would put it as a null route, pretty much.
Exactly. So if I had a bunch of small, more specific network statements, like I prefer to do my OSPF,
Then you need to summarize it.
then I would need a summary route, which I would normally do with a null route. There are other ways to add summary routes into BGP. This is the one that we're going to learn and focus on. Because there's all sorts of wacky stuff you can do with routing, like policy-based routing, address families, and virtual routing tables, and all sorts of wacky shit. We're gonna get the basics down. Okay, so eBGP and iBGP. We've got some differences, we've got some similarities. These are the differences. So eBGP is a BGP peering between routers in different autonomous systems. They have different ASNs. That has an admin distance of 20. We trust it a lot, because generally we're peering with a service provider. Someone that we implicitly trust because we are paying them a lot of money to provide us a service. Internal BGP is a peering between routers in the same autonomous system. They have the same autonomous system number. This has a much higher admin distance. It is less preferred. And it also has a full mesh requirement. What that means is for each router that you have, they must have a direct connection to every other router. Which isn't bad when you've got 2, 3. But when you start getting into 5 routers, you add another one over here, now it has to connect. And then another one over here. That becomes a mess real quick. One,
Looks like spaghetti.
most routers just don't even have that many ports. 2, that's a jumbled mess. So there are some ways to get around that full mesh requirement. We're not going to talk about them right now. We'll save that for the advanced routing lab once you're greenlit. But know that this full mesh requirement exists, and there are a couple ways to get around it. Okay, let's set up BGP. So, creating the process first, router, BGP, and then our autonomous system number. You can only have one BGP process per device, by the way. So, just in case you were wondering.
Wait, what do you mean?
So, like with OSPF or EIGRP, you could have OSPF 10, OSPF 20, OSPF 30. With BGP, you can only have one. We are then going to add networks to our BGP table using network statements. So, network address, mask, subnet mask. These are the things that already exist in the routing table, and we want to add to the BGP table. Whoops, hang on.
So what if you have more than one ISP and you only can set up one BGP?
You don't need to set up more than one BGP, you set up multiple neighbors.
Okay, gotcha.
So, like we have right here, this would represent 2 different neighbor connections.
Gotcha.
For 2 different ISPs. So, neighbor, the IP, specific IP address of that neighbor, and then what autonomous system number we expect them to have. You make 2 different statements, set up 2 different neighbor relationships. Additionally, neighbor, you won't just have a neighbor command to form a relationship. If you have specific parameters for a neighbor, you will also put those parameters as a neighbor statement. So, I'm forming a relationship with Comcast, which is represented by Alex.
In the Comcast.
I want to receive, or I want to cache a local copy of what he's sending to me before I apply my filter. So I would say neighbor, Alex's IP address, and then soft reconfiguration inbound, which is an additional command that I can apply to it. So that's saying, for this relationship, add this additional parameter. That's also how you apply filtering, which we'll get to when we get to the filtering lecture. You know, this relationship, I'm applying this specific filter.
Okay.
That way, I only receive certain things from him and I only send certain things to him. Because I could have 30 things in my BGP table, but I only want to send him one specific route. I accomplish that through filtering. And you apply that filtering on a per neighbor basis.
When you're going into the router BGP 65501, it always has to be a number. It can't be like just a title or
Has to be a number, autonomous system number.
Makes sense. It's in another.
Our hands look like this so that all the peasants can use DNS. Just is a fact of life. Okay, and then if we want to redistribute, so I want to take the routes from OSPF number 175 and I want to add them to BGP. So as long as I'm in BGP, I type redistribute OSPF 175. And then if you wanted to do the opposite, take the BGP routes and add them to OSPF, you would go into the router OSPF process, redistribute BGP, and then the autonomous system number. Tablet, please. There we go. All right. Verification commands. To see the BGP table, it's real easy. Show IP BGP. To see a list of our configured peers, what their current state is, and the number of prefixes that we've received from them, we can use show IP BGP summary. So when you want to look at your neighbors, you use BGP sum. And you remember how I was talking about how BGP is an intentionally slow protocol? Sometimes you need to just kick it in the pants and clear out and make it resend everything. The way that you do that is this command here. Clear IP BGP star soft. That forces BGP to reset and send the advertisements again. So if you're not getting a network to share with your neighbor, sometimes you just need to clean out the cobwebs and have them start fresh. That's a condition that you'll typically see when you're making a bunch of changes to BGP when the neighbor relationship is already up. And it just is like, what are you doing, man? All right.
So it's like a reboot in a way.
Yeah, it's a soft reboot. There is also a hard reboot where it tears down the entire neighbor relationship and reforms it from scratch. In order to do that, you just take the soft keyword off. So it's clear IP BGP star. And you can do the same thing for any of the dynamic routing protocols. Clear IP OSPF star, that'll reset the entire OSPF process. Not something you typically want to do on a production network during the middle of the workday. But, you know, sometimes life is crazy. All right. To view routes received from your neighbor, show IP BGP neighbor, the IP address of that neighbor, and then received routes. Pay very close attention to your spelling here. I before E, except after C. We got a C in there, so it's CEI instead of CIE.
Let me questioning my spelling for a second.
Now, in order to actually see these received routes, we must have already configured soft reconfiguration inbound. That's that thing I was telling you about a little bit earlier when I was talking about other neighbor commands.
Right.
What this does is it stores a cache, a separate little database of all the routes that it receives before you apply filtering. Now, the reason why we want this cache is because 99% of the time, when you're troubleshooting a BGP problem, it's not a BGP problem, it's a BGP filtering problem. So if you see the raw input compared to the filtered input, you can see if, hey, did I get this route at all? Yes? Cool. Did it make its way through my filtering? No? Well, then the problem is my filtering. I need to go fix that. If I didn't receive it at all,
It's not a filtering issue.
well, it could also be a filtering issue, but it's also some other issue at the same time. So it gives you a place to start looking. So in order to set that up, and this should just be enabled by default, but for whatever reason, the Internet Engineering Task Force hasn't just made it a default value, so we have to manually configure it for each neighbor. So you do neighbor's IP address, soft reconfiguration inbound.
Yeah, I felt like that should be default.
I just set that up on every BGP neighbor I ever make, no matter what.
It's just more steps. I feel like it should be default.
It should,
Yeah.
but in the same way that we still use wildcard
Yeah.
for EIGRP and OSPF, it shouldn't be that way, but it is.
Or that word, like, when I was doing, SCP, bridge, they still use bridge, when bridge was like, back in the day where they used to connect. So now it's just a term for switch.
So, bridge is tricky because it has multiple meanings. So if you're in the middle, something goes wrong and there's an outage, you will get on a bridge, which is a fancy way of saying a conference call with the technical assets to say, what the fuck happened and how do we fix it? But it can also refer to a switch, like you alluded to. That's one of the things when I went into the field, I was like, wait, what? So now you know. And not everyone uses that terminology. A lot of places do. So, yeah, if someone ever asks you about an incident, yeah, this went down. The first thing we did was we opened up a technical bridge, started talking about it, examined these 5 things, found this problem, went back to the bridge, came up with a solution, implemented the solution, resolved the outage, closed the bridge. Wrote an after action report or a root cause analysis. That's the typical workflow of an outage. Unless you're all in the same room, in which case you don't need to open a technical bridge.
Yeah.
You just talk to each other. All right. So to view the routes that are being sent to your neighbor, show IP BGP neighbor advertised routes. And lastly, to view the routes that you've received from your neighbor after filtering, it's just routes. Write that down. So received routes is before filtering, routes is after filtering. Okay, are there any questions about BGP before we continue?
It's interesting.
That was the basics of BGP.
Yeah, I was gonna say it's not that new.
We're not done yet.
Wow, so from my own personal experience, as well as just observing groups going through, we found that throwing BGP and BGP filtering at you at the same time confused the hell out of people. And by splitting it up into 2 separate lectures, getting you to work with it a little bit first in scenario, 4?
4, yeah.
And then work with it in a more advanced form in scenario 6, helps with retention and comprehension and understanding, breaking it up a little bit. And you don't strictly need filtering in order for BGP to function. You just won't ever find it in a production network without filtering. Because I don't want to be receiving the routing table of the internet on my device.
Is it?
It'll blow the fuck up.
Freaking.
I hope I'm using a right
Crash it.
wording. Is it part of redundancy?
No. So redundancy will be our next lecture. Filtering will be after that. Because there's more than one type of filtering. And so rather than split it up into like 3 different lectures, we're just gonna do all filtering in one lecture. Because they all operate kind of the same, or along the same principles, there's just different syntax and wording for them. And where you put them. Okay. Network address translation. Network address translation is a category of protocols. We are specifically going to look at PAT, port address translation, today. During the tunneling lecture next week, we'll talk about a couple other types that aren't really used anymore but do exist. And they do have some practical applications, they're just few and far in between. So, NAT is the process by which a host that does not have a valid, registered, globally unique IP address, aka public IP, to communicate with other hosts through the internet. So if you don't have a public IP address and you want to talk to somebody on the internet, you need to go through a device that has a public address and can translate for you. Act as your go-between. Another way, or another word that you'll hear is proxy. So that it is representing you to the public internet. Now, you'll usually hear proxy in different contexts related to firewalls and load balancers and some other security appliances, but it does still apply here as well. Because we're going to be using routers to act as our NAT devices, and they are still representing the private address to the public internet on our behalf. They are a middleman.
So I seen the word NAT when I was playing games, and it would say NAT closed or open. Does that have any relation to? It'll be when I'm like matchmaking with somebody or trying to connect to a server. It will say.
What game were you seeing that in?
If you go on the PlayStation, you'll see like NAT type 1, NAT type 2.
Oh, yeah.
It's weird.
I know what you're talking about.
I just don't know if it's any.
I've looked it up in the past, what that actually means, because the PlayStation Network, for whatever reason, the PlayStation Network has their networking stuff set up super fucking weird.
Because they got hacked.
Yeah, they did get hacked.
Well, so I think what's going on there is the PlayStation itself is doing NAT, and then when it gets to your private modem / router, which is normally what's doing NAT for you, because it's already translated, it's trying to translate it again, and it does some wacky shit, and it doesn't work right.
Yeah, because usually when it's NAT closed, when you see that, you're gonna have some matchmaking issues where it won't work or you won't. But
Yeah, there's some specific goofiness when it comes to PlayStations with NAT. Nintendo, Microsoft, they don't have that problem because they handle it in a different way. I don't remember exactly what it is, but if I'm remembering correctly, that's roughly what the problem is the PlayStation is already natting full.
Gotcha.
And so when it tries to double nat, it gets fucked up. Okay, so NAT achieves this goal by using a valid registered IP address to represent the private address to the rest of the internet. All right,
Source and destination.
here's a visual example of what's going on.
Info.
So, our client, PC, 10.1.1.1, it wants to talk to this server for whatever reason, maybe it's Yahoo Mail.
It's Reddit.
So we know the IP address of what we're trying to talk to, the 170.1.1.1. We send our packet saying, hey, we want to talk to this server. It arrives at our edge router. That edge router sees the packet, looks at its destination and its source IP address, and says, whoa, whoa, whoa. We can't put a private IP address into the public internet. I don't want to break the internet today. Because that has happened before. Don't be the guy that breaks the internet.
Tough.
We need to substitute this. So I see you're trying to go to the 170.1.1.1. I'm going to see what I've got available, and we'll give you a replacement address. And so, just like every other protocol that we've been talking about, NAT maintains a table, a record of what it's translated to what and what it was trying to talk to. So we see that, okay, we've got 200.1.1.1, that's an available address. We're going to rip off your layer 3 header, record that information in the NAT table, and we're going to build you a new layer 3 header with 200.1.1.1 as your source IP address. Fire that sucker out into the internet, gets to our server does whatever it is that we're asking it to do, and it sends a response. That response makes its way back to our NAT device, which sees a destination of 200.1.1.1 from the source of the server. It looks in its NAT table and says, yep, I have a record for this. That 200.1.1.1 from 170, you're actually trying to talk to 10.1.1.1. Let me fix that for you. It rips off the layer 3 header again, rebuilds it with the correct destination IP address, and then forwards it back into our private network, where it eventually arrives at our endpoint. Does that make sense?
Oh, yeah.
So it's just substituting that public address when it needs to be talking to the public internet. And it keeps track of all these conversations.
So what, NAT tricks? It tricks it?
It doesn't trick it, it just is a proxy. It represents, so we've got, what, like 100 different workstations here? If they each had a computer, well, do we have 100 public IP addresses?
No.
No, that would be expensive as hell. So, what we do instead is we have a address, or 2 addresses maybe, and we use those to represent all of these to the public internet. That's how we're able to conserve IP space. We'll explain how in a little bit here, because it uses some additional stuff. That's why we're learning PAT, port address translation, not base NAT. So PAT is network address translation, the process that we just saw there, only it adds a port number onto it, a port address. So in that NAT table, in addition to the source and destination IP address, It also adds a source port and destination port. That way we can use the same public IP address over and over and over and over again. Because if someone else makes a request they need to talk to the internet, we just give them a different port address, different port address, different port address. We can do that 65,000 times for a single IP address. Most companies aren't going to have so much traffic that you end up exhausting that list of port numbers. And even if you do, the way that you fix that is you add a second public IP address. You just doubled it to 130,000. So instead of having 65,000 public IP addresses, we can have one. And it keeps an entry for each unique combination. This allows us to drastically reduce the number of public IP addresses that we have that are required for our network to function. Every company on the planet does this. All of your homes do this. Although with residential internet, it's a little bit different. We're not going to talk about it in detail, but the ISP handles it all for you.
Nice.
Because they're translating from IPv4 to IPv6 anyway. It does some wacky internal shit. That's that CCIE level service provider that we're not going to go into. It's really cool. Not going to go into it right
Don't
now.
have enough time.
You got enough in your brains at the moment.
Trying to keep
True.
it all in
I know.
My brain is right now,
Overload, Pat.
See, this is why we broke it up into multiple lectures.
Thank you. Thank you.
Should record you should start recording the classes with their faces when it gets to this part right here. Just
Recording.
Yeah, I
everything.
know.
Yeah,
No, I got it so far.
I'm definitely
If
need
you've
to
never
review.
heard it before, there's a phrase "death by PowerPoint," and I am violating a couple of the rules when it comes to death by PowerPoint on this slide. But the unfortunate reality is sometimes you just gotta vomit a bunch of words onto the screen and get them all down because they're all necessary.
That's
It's
I know
a
what
lot
you mean.
easier for you guys to copy this down in written form than for me to just regurgitate it to you verbally and you have to try and record it all. So, rules are meant to be broken, but only break them when it makes sense to. And when you're not gonna get in trouble. And by trouble, I mean commit felonies. Because that's an easy thing to do in our job. Don't do that.
it's not illegal if you ask permission.
No, it's still illegal. The FBI just knows that you're coming. So every single one of these devices has cryptography information in them. Cryptography meaning
it records.
encryption.
Passwords.
There are multiple cryptological zones. The United States is one. It is a cryptological zone. Canada is a separate cryptological zone. So is Mexico. It is illegal federally to send a device from one cryptological zone to another. Don't do it. Buy your equipment in the country that it's intended to be used in. Don't commit a felony.
So if you buy like some secondhand equipment from Canada or Mexico, you can't use it because it's not bought in the U.S.
Importing it would be illegal.
Oh wow, that's interesting.
That's why when Linus was doing his preview of his updated Wi-Fi for his house, he was talking about, yeah, I'm committing a felony right now, but I just don't care.
Yeah.
Because he, the
Secondhand
APs that he had in his home were Wi-Fi 6E capable, but Canada's version of the FCC hasn't, like, officially created the frequency range for Canada for Wi-Fi 6E. So he set it up to be US and was broadcasting on the US frequencies, which is very fucking illegal.
Holy shit.
Don't do that. But
You just said that on YouTube? Like, on
Yeah.
one of his videos?
straight up, yeah, this is really illegal, but we're gonna do it anyway.
Wow.
Because it doesn't matter for his one house in the middle of the woods.
Yeah.
They don't care.
Well, if you set it up for his business, I would imagine that would probably...
Yeah, for
Very different
enterprise.
story.
Yeah.
Interesting.
But yeah, so cryptography, frequencies that you're broadcasting at, all very highly regulated. Buy stuff where it's intended to be used. The EU is a little different because the entire EU is one cryptological zone. So you can buy a router in Italy and ship it to Germany. Not a big deal, because it's all part of the EU. But if you go from one zone to another, that's when you have problems, particularly with China.
Oh, yeah.
Huawei.
I can only imagine.
Does Canada use the same power voltage?
No.
No, okay. Because I remember in the Middle East it was different than here, so I had to like mod my equipment.
Yeah. And that's one of the other problems is a lot of places use different power
China
standards or even just plugs like you were referring to. So that's part of the reason why shipping equipment internationally is not a good idea. Because Cisco makes specific versions of equipment to work with specific types of power. That's why if you go to the Cisco website and you're in Germany, it redirects you to a German-specific website where you can buy equipment that is compatible with your electrical infrastructure.
Gotcha. No Huawei.
Short story long, buy stuff in the country that it's intended to be used in.
Could they just like drum up the prices though, because they're the only manufacturer and way to get it?
I mean, they do that anyway.
Oh, okay. I see.
Okay. So, Pat, very similar process. This guy is trying to talk to our server here, right? We make a stop at our NAT device. It records our inside IP address, inside local, meaning private. It assigns a port number to it. It translates it to a public IP address, which also has a port number assigned to it. Packet goes on its way. Shortly after, this computer does the same thing. Those are two separate private addresses that are both trying to get out. We repeat the process, but we give it a different port number.
It's just like the telnets that we're looking at, right? Just same.
Exactly.
That's what
Those
it
are
is.
literally what we're talking about.
Okay.
Those are port numbers.
Right.
These are just, what's the term for it? These are ephemeral port numbers. So port numbers get broken up into two categories. There are well-known, which are, internationally agreed upon. This port is used for this purpose. A good example of that would be Telnet or SSH. They both utilize a specific port number. Telnet is 23, SSH is 22. HTTP and HTTPS, same thing.
80?
Yep, uses 80 or 8080. It has two well-known ports. And HTTPS uses, you know it?
440. No.
You're close. You had the first two digits right.
4023?
Oh,
That's not the first two digits. Do we need to have a remedial math class, Alex?
Yes.
443 and 8443. These are well-known, established port numbers that are utilized for a specific thing. We just learned about another one earlier in this lecture. What is the port number BGP uses?
GP.
Trying to remember it.
BGP will use 179 on TCP.
TCP. You have to be specific. Because BGP is a reliable protocol, it uses TCP 179 specifically. So, for the most part, you just indicate what port it is. You don't worry about the protocol. But with certain things, you have to specify. Because you can have UDP 179. And because it's a different protocol, even though it's using the same port number, it's handled differently. Okay, so these are well-known ports. They fall into a category of commonly used ones, like World of Warcraft has a well-known port. I don't remember what it is off the top of my head, but it's like 2037 or something. So certain things that get used a lot get internationally recognized, and that port will be reserved for them, basically. Now you can set up any server to listen on any port, but if you set it up to use one of these well-known ports, you're gonna get all sorts of goofy jumbled shit. And frankly, that's not our business, that's the server team's business. But just keep it in the back of your mind. You can set up a server to listen to any port with any protocol. Now, on the flip side of that, ephemeral ports. The ones that are not well known. So this is all the other port numbers, all the way up to 65,535. Hey, look. That number looks familiar.
It does.
Where have we seen that before?
I don't remember.
It's the same number as BGP.
Yeah, I was gonna say I was looking right at it too.
It ranges from 0 to 6, 65535.
So, I think it's 49,000 through 65,535. These are all ephemeral ports. And the number may be lower. But they are ports with no specific purpose. And so they will be utilized by protocols like NAT to represent private IP addresses to the public internet.
Makes sense.
And so because they are ephemeral, they're not designated for a specific purpose, our NAT device will just
Give them a
pull from
purpose.
that pool freely.
So that it can always be random, right?
Yep,
And that will always, it doesn't matter which port, as long
Yep.
as it's ephemeral.
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 It's okay. Look at it. It's a weird word.
Yeah, I haven't heard of the word. Ephemeral.
Does that make sense?
Yeah,
Yeah.
You tracking? Cool. All right.
How much is there left?
Configurations, verifications, and then we're done. All right.
Go off this one.
So we've got a fair bit here.
And that inside and that outside.
We need to make modifications to our interfaces. We need to create an access list, and then we need to set up PAT itself. So we're going to walk through those things one at a time. We'll start with our interfaces.
Can you say that again? So you said it'd be interfaces. What's the third one?
Access control list,
Access control list.
ACL. And then we're going to actually create the NAT process.
So then create that process.
So, in our device, we're going to use router Illinois here as an example. California, New York, Illinois, Comcast. We've got 4 interfaces in use. What what NAT does with these interfaces is you need to specify where you're expecting the translation to happen. So for ours, let's say G01 is our Comcast. Got it set up like this, right? Which of these interfaces is going to have a public IP address?
G01.
G01. What about the other 3?
They'll go through
Private IP
Yep.
addresses, right? So,
They're on inside.
right. So this router is acting as our edge, our border, our gateway, our demarcation. We have control over everything that's going on within our own network. We do not have control over what is going on in Comcast's network.
So that's where the demarc is.
Yes. So demarc. Inside our own network, that things that we have control over, we specify those as being inside ports. If it is leading outside of our network, like G01, because that's going to Comcast, that is our outside port, or ports, if you have more than one. So, when traffic comes from the inside and is trying to get to the outside, that's when the router will actually check our NAT configurations and see what it should do. If our traffic is just flowing from California to New York and back, we're staying inside our own network, we're not even going to look at our NAT configurations. We don't care. But if it's going from the inside out or the outside in, we check our NAT configurations. What do I do with this? Does that make sense? Okay. So, setting up the interfaces is real simple. You go into the interface in question, and you put IP NAT inside, or you put IP NAT outside, depending on if it's an inside interface or an outside interface. Now the first one you do, the router is going to start up the NAT process, so it'll probably lag out for a minute. Don't get freaked out by that.
I'm freaking out.
Well, depending what's going on, it may throw some errors like CPU hog and whatever. Don't worry about it, just let it sit and do its thing, it'll figure itself out.
Question.
Yes.
Why does it say interface serial 000/0/0/0?
Great question. So,
Why is it the serial?
serial is another type of interface. And the 0/0/0 is indicating what physical device it's on, what ASIC or line card it's on, what port on that ASIC or line card. So, what I mean by what device it's on, you can stack devices together. This is a more advanced topic, we're not going to get super detailed into this. Basically, if you have multiple devices that are going to be doing the same job, you've got like 3 switches that are all going to be in the same access closet, you can just connect them all together so that instead of managing each one of the 3 individually, you manage them as one logical device.
Under
What?
serial.
So you just daisy chain them together?
Yeah,
So we just
well,
go into that one and we can check on it.
it's not a daisy chain because there is full redundancy in how you do the wiring.
Oh, okay,
but-
I gotcha, yeah.
But yeah, you connect them all together and they will communicate with each other through their backplane.
Gotcha.
What was your question, Mike?
It's just about the general like wording for redundancy, isn't it having a proper structure for the network, making sure it's set properly?
So redundancy is a category of protocols as well as a design mindset. You don't have to have redundancy. You're an idiot if you don't. And there's plenty of those out there.
If you want plenty of calls. It's
And
not
you
fun.
know what?
That's what.
They guarantee that we have jobs, so I'm okay with it. We'll come in and fix your shit. As long as the check clears.
Yeah.
So stacking switches together is a form of redundancy,
Okay.
technically. Realistically, you're usually doing it simply because you need more ports. You know, if you've got 50 drops in this area, well, my switch only has 48 ports on it. I need a second switch. And rather than managing them both separately, let's stack them together, split the ports up evenly, and manage it all as one big device. It's a lot easier that way. And the stacking, like protocols and infrastructure, really easy to do. So we're not going to go into that in detail at this time, but just know that it exists. It's not too hard to work with, and it's something that's pretty commonplace.
I'll come back to it.
Okay, so we set up our interfaces. Next, we're going to hop down here and make some ACLs.
Let's see.
Access control list. We'll go into this in more detail in the filtering lecture. For right now, just make the ACLs that John gave you exactly as he gave them to you. What this is basically
Block it.
in the same way that a trunk port is checking to see are you on the list of approved VLANs, this ACL is acting as a list, are you on the list of approved IP addresses? Are you allowed to be NATed?
Okay.
And lastly, we need to create the NAT process. So, IP, because this is all happening at layer 3. NAT, because we're doing network address translation. If a packet comes to our inside interface, check this list. So that's the ACL that we just defined right here. And if it's on that list, then give it the IP address of this interface. Substitute that IP address. And because we added the overload keyword, give it a port number too.
It's a long command.
Yeah. NAT is one of those things that it ends up being a pretty complicated config, simply because there's a lot of different ways to do it. For instance, we could give, instead of saying interface, we could give a specific IP address. Or we could even give a pool of IP addresses. How you configure it is dependent on the situation that you're in. Right now, use the configs exactly the way they're written on the LLD, and you'll be fine.
Okay.
All right. Write this one down. So this is from the outside in. So in the previous one, we specified IPNAT inside source list. So if it's going from the inside out, do this. This one is IPNAT outside source list. So if it's coming from the outside in, do this. So this is an example of a pool of addresses. So if you're coming from the outside in, check this list. If you're approved and allowed to be NATed, take an address from the pool named internet and add the route. So this keyword right here, pool, is telling you to reference this NAT pool that we created in the step before. And this is the name of that object. Now, you generally won't be doing outside source lists like this. Usually the carrier takes care of this stuff for you. In our scenario, because we're natting on both sides and we don't have carrier NAT in the middle, we need this in order to make it function correctly. It's a goofy thing specific to our environment because I didn't want to learn how to do service provider level shit.
Fair.
So the pool type is the internet? Is that what you're saying? I mean,
It's not the type, that is the name.
okay.
So, create a pool of addresses named internet, starting with this address, ending with this address. It is this big. So it's specifying what addresses are available to it and how many addresses there are total. Don't worry too much about understanding this particular configuration. All right. Come on, last page, just work. All right, NAT verifications. To see everything that is currently being translated. To see the NAT table. Show IP NAT translations. To see historical data. Show IP NAT statistics. Now, the NAT table is a very short-lived table. So if you ping something, talk to your neighbor for 2 minutes, and then go to try and look at the translations table, that entry may already be gone. And it'd be like, oh, what? My NAT didn't work. Well, it did, you just missed it. And so you can look at the statistics to see that, oh yeah, I have translated some packets, and the number of packets I've translated increased by looking at historical data.
Interesting.
Are there any questions on that?
You said the translation.
Not yet.
Translations was the short-lived one?
Correct.
Okay.
That is what is currently translated in the table. All right, that's all I got. If there's no other questions, then we're done with lecture for the day. We'll do your presentation.